All right, this is our last section in Chapter 9. Chapter 9.1 was just talking about boundary points and expressing inequalities graphically and in word form. 9.2 that we just finished was on one-step inequalities, isolating variables and solving them. And the last one we're doing here is just multiple-step inequalities, which is just a little bit more. Usually it involves a constant and a coefficient together, or in the case of B and C, distributive property or variables on both sides. So our exemplars here will illustrate this point fairly easy. It says solve each inequality and then verify your solution. So we're going to do just that. So with the first one, I'm going to subtract 11 like I would if it was an equality from both sides. And I'm going to get 4x has a value that is greater than 24. Once I do that, same thing I would do in an inequality. I divide both sides by my coefficient to isolate the variable and realize that any value greater than 6 would fit that truth. So when I make my table of numbers that are representative of that, I get 7 as the first integer, 8 and 9. All three of those are values that are greater than 6. I'll put my dot, 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 because it does go past that. And those are values. So that's solving in each equality. The last part says to verify the solution. So how will I verify? How will I verify? Anybody? Yeah, I'm going to substitute one of them. Normally, I like to take my middle one and just take your middle number and substitute and make sure that is a valid number. So if I take that number, I'm going to take my original inequality and I'm going to substitute 8 for my x. And if this is true, then my inequality is likely true. I get 8 times 4 is 32. 32 plus 11 is 43. And since 43 is a number that's greater than 35, I verified that 8 is a valid number, and I have verified that that's probably the correct solution. Question B gives the inequality of the expression 5 minus 2 times the value of a number will have a value. That expression's value will be greater than taking that same number, multiplying it by 10, and adding 29. At first, if you just think of it rationally, this seems like x would be an impossible number. Right? When you look at it, 5 take away 2 times a number will have a value greater than multiplying that number by 10 and adding 29. To the untrained eye, what does that mean that x is probably? What kind of value? Do you think it might be a big number, a small number, a negative number, or a positive number? Anyone want to guess? Maybe negative? Maybe. Let's see. So what do you think our first step in solving this inequality will be? Well, when we did Chapter 8 on double equations where there were variables on both sides, we always said get rid of the variable on one side by using the additive inverse to get rid of it. So in this case, the minus 2x, if I add 2x to this side and add 2x to this side, that's a zero pair. I'm left with 5 is greater than 12x plus 29. Once I get it here, it's very familiar. Subtract 29 from both sides. 12x is less than negative 24, correct? And once I get that, divide both sides by 12. At any point, should I flip the sign yet? Did I have any reason to flip the sign yet? Where? Right here? When do you flip the sign? When you multiply or divide by a negative number. Since I have not done that, I do not flip the sign. So my answer, when I read this, will be all numbers or all values less than negative 2. That's what this says. All values less than negative 2. My set of values that that's valid for, numbers that are less than negative 2 would be negative 3, negative 4, and negative 5. Those are my first integers, whole number integers that are valid. In order to verify, okay, let's check now. So all values less than negative 2, my I put -3, -4, -5, right? Okay. I'm going to choose -4. I'm going to substitute it in here. So 5 minus 2 times -4 will have a value greater than 10 times that same -4 plus 29. Let's see if this is true. So 5 minus -8 will be positive 13. -40 plus 29 is -11. Is 13 greater than -11? Yes. So I verified that it appears that this set will be values that are work. And I could check -3 if I wanted to and go through the whole rigmarole, but generally speaking, you check that middle number. If it works, you probably have the right answer. And the last question, C. Sorry. C, we have 4 times x minus 2 is greater than or equal to 5x minus 12. Go ahead and try this on your own, and then we'll see if you're right. So obviously we have variables on both sides of our inequality, but we also have the multiplication of a monomial by a binomial, which will expand using distributive property. And once we do that, we have exactly like B was. We just have variables on both sides. Remove 4x from both sides is the most efficient way, but not the only way. The solution would be all values less than or equal to 4. That's our solution to our inequality. So all values less than or equal to 4, if we put 4 here and 3 here and 5 here, open or closed, all values less than or equal to means it's a closed boundary point. And my number line goes here. Numbers that are included on that set are 4, 3, 2, to infinity and beyond. It says verify the solution, so we have 4, 3, 2. I'm going to go back into here. I'm going to pull that down here. Just put it down there for a second. Substitute. Let's do 3. Actually, you know what? For poops and giggles, let's go with 4. Let's substitute 4 for that. What do we think is going to happen if we substitute the actual first number in an inequality where it's less than or equal to or greater than or equal to? They should be the same on both sides, right? So 4 times 2 is greater than or equal to, oh, I forgot to substitute here, didn't I? 4. 20 take away 12. 8 is greater than or equal to 8. That is true, and therefore our solution or our set of numbers is likely true. A smart person would check 3 just to make sure, but I'm lazy, so I won't.